Good morning, good afternoon, hi. My name is Maciej Beronsewicz. I'm from Poland and I will be presenting you the package called nonprobsvy, which main aim is to provide set of methods that you can apply to correct selection bias for non-probability surveys. The presentation is as follows. So first I will introduce you to the problem. I will present myself as well as the methods that are implemented. Then I will show you how you can use the package, the main function, and some examples, and I will discuss the future. So first of all, I'm from Poland. I'm from Poznań. This blue dot denotes the place where I work and where I live. So I work at university and statistical office. In particular, I work at Poznań University of Economics and Business and statistical office in Poznań. So the motivation for the work was connected both to the problems that we deal with, that we encounter in official statistics, declining response rates, and using non-probability surveys for population inference. And because I work at the university, so I'm interested in methods that sound statistical methods that allows us to correct the selection bias. So I'm employed at the Department of Statistics at Poznań University of Economics and Business, and I'm also the head of Center for the Methodology of Population Studies at Statistical Office in Poznań, which is a regional office of Statistics Poland. My main focus is survey sampling and methodology, including the survey sampling, the problem of non-response and calibration, and these very non-probability samples that the presentation is about. But I'm also interested in estimation of the population size. Currently, I am the PI of the project towards census-like statistics for foreign-born populations, which is founded by National Science Center in Poland. But recently we also got a new project which is focused on online job advertisements, OJA Lab. I'm also an R enthusiast. I organized several R conferences in Poland and Europe. For example, European R users meeting in 2016. So I've developed several packages. Some of them are on CRAN, some of them are still on GitHub. I worked on a nonprobsvy package. I am on another package which is devoted to population size, which is called single R capture, joint calib, and blocking for record linkage. If you are interested in the details behind the package, because I imagine that the presentation is quite short and the goal of the presentation is not to focus on particular methods. If you'd like to follow what we've implemented, please go to archive and look at the paper that I present here, which was currently submitted to the Journal of Statistical Software. So in the package, we've implemented several of approaches that were recently presented and discussed in papers, like for example in the Chen, Li, and Wu paper that was published in Journal of the American Statistical Association. They studied the statistical properties of doubly robust methods for non-probability samples. They derive closed form estimators. They study the properties of the IPW estimators and the others that they proposed. In the same year, there was another paper published in Journal of Royal Statistical Society, Series B, where the authors dealt with the high dimensional data, which is quite crucial if you have access to, for example, admin data and survey data with long questionnaires. There is also a paper on mass imputation, which was discussed in this paper by Kim, Park, Chen, and Wu. And in general, we follow notation that was introduced by Changbao Wu in the review paper recently published in Survey Methodology, where he discussed various methods that you can apply to correct the problem of selection bias for non-probability samples. We also developed several methods by our own. For example, recently accepted to survey methodology, planned to be published in December 2025. The method that accounts for quantiles and allows you to reproduce quantiles with inverse probability weighting. So why another package for non-probability samples? In R, we have a couple of them. For example, nonprobsvy package, weight it package, which actually focus on causal inference, and GJRM package, which mainly focus on selection models like Heckman models. In general, those packages unfortunately are limited in terms of the approaches that can be applied and how the variance can be estimated. None of these packages are actually integrated with the survey package, and there is lack of implementation of the current solutions presented in the literature. So the motivation was to develop a tool that enables the user for consistent application of different estimation techniques. The package is already on CRAN, with the version 0.2.2 and is still under development, so we encourage testing and commenting and tracking on GitHub. So the package, what is unique about the package? It provides an easy to use non-prob function that mimics existing R functions. For example, we use formulas. It has a full integration with the survey package. It implements both analytical and bootstrap variance estimators recently proposed in the literature. We also extended the state-of-the-art methods in various ways. In general, we have implemented the following approaches: inverse probability weighting with possible calibration constraints, mass imputation estimators based on nearest neighbors, non-parametric methods and regression imputation, various doubly robust estimators, and we also allow user for variable selection in high-dimensional space using SCAT, LAS, or MCP. And the package has many more features. So what is the basic setup? So in general, we assume that we have two approaches. One approach is that we have only population level data. For example, we have some reports. We do not have access to unit level data from registers, so we have totals, means, and population size. On the other hand, if we have access to survey data, it's better, because if you have access to reference probability sample, we have more possibilities in terms of estimating of population means from non-probability samples. So what is the setup? Setup is a two sample problem. We have or data fusion or data integration. So we have two samples, non-probability sample SA and probability sample SB. In the probability sample, we have sampling weight, right? We know the inclusion into probability samples, while for non-probability sample, the inclusion is unknown. So we do not have any information on the mechanism that resulted in a given non-probability sample. Fortunately, in both sources, we have covariates, which we assume that are measured on the same scale and have the same definitions. And we are interested in some study variable y, which is observed in non-probability sample, but for probability sample, it's missing. So what are the possibilities? Here you have two calls of non-prob function, and the call how you specify the arguments. It points you to specific estimators. For instance, on this slide, I'm presenting you how you can run the mass imputation based on regression imputation. So if you specify the outcome, Then by default, we assume that if the outcome is specified, then you are interested in the mass imputation. And here, if you specify population totals, it means that you specify only a vector of information that you have. For those of you who are familiar with survey package, this is the similar way how you specify the population totals for calibration. Then in the mass imputation on the right side, you see that the argument pop totals is missing, but instead you have survey design. So this is a case where you have a reference probability survey. So as you can see, if you specify population totals, then it means that you have only population information in form of vector. If you specify survey design, then it means that you have access to reference probability sample. If you are interested in correcting the selection bias by using the inverse probability weighting, then you need to specify two arguments. Specify the selection, which informs which variables you would like to use to estimate the probabilities of inclusion for each unit in non-probability sample. And if you specify the target, then you need to specify the variable that you are interested in. What is interesting is that you can apply the IPW also if you have only population total. So if you have only the non-probability sample and reference population totals for the variables that are present in non-probability sample, then you can correct for selection bias. Another possibility is to provide the survey design argument with the reference probability sample, and then we're estimating the probabilities of inclusion to non-probability sample. And if you are interested in doubly robust estimators, you need to specify both. If you specify selection and the outcome, then we assume that you are interested in doubly robust estimator. You can estimate the population mean both if the pop totals is provided or if the survey design is provided. So these are the main calls of the non-prob function, and this is the main function of our package. It has many features, many control arguments. This is not the right time to present all the details. If you're interested, you can look up in the documentation. So these are the example runs of the IPW and the doubly robust methods. So I'm specifying the selection, I'm specifying the target and the outcome for the doubly robust estimator, and how you can see on the next slide the print. It's quite similar to weighted package. Actually, we were motivated by the output of the weight it package, so it resembles it. We have information about the estimator type, we have information about the method. What is more, we provide the naive uncorrected estimators as well as the corrected estimators along with the standard errors and the 95% confidence intervals. So the similar output you will get for the doubly robust. You just see that you can see that the difference is in the names. So you have the estimator type doubly robust. You have the method similar as on previous in previous approach you had logit. Here you have GLM with Gaussian. Then you have information about selected estimators along with the standard errors and confidence intervals. Note that we provide this print up to five variables. If you provide more, then it will not be presented. If you run summary, you will get information about the sample sizes and the distribution of weights. We also have some simple plots where you can compare the naive estimator presented here by triangle, and the corrected ones that are presented with the points and the confidence intervals. We also have several methods that allows you to extract the coefficients, estimate the confidence interval. Also, you can you can update the object. You can extract the weights. We have also some functions that are mainly for developers. In particular, if you are interested in running a specific method, like for example method GLM. And in argument and in functions control inf, out, or cell, you can specify control parameters for inference, for the outcome model, and for the selection model. So what is the future? In the future, we plan to account for overlapping samples, for the replicated weights. We would like to use the calibration approach. For example, quite popular empirical likelihood that unfortunately is now missing. We only support one non-parametric method for mass imputation only, and we plan to extend it for different approaches. We currently only focus on inference for the mean, and I know that users are also interested in inference for quantiles. We do not account yet for the mixed mode, where you have non-probability and probability sample that measure the same, which is quite common situation where you would like to use the bigger non-probability sample with some small probability sample. We plan to implement pseudo population bootstrap for variance estimators and many others. If you have ideas, please let us know, and if you like the ideas behind the package, we would encourage you to leave us a star on GitHub. If you'd like to discuss the methods, or if you'd like to provide us details about the methods that you would like to implement, to be the methods that you think that would be nice for us to implement in our package, we strongly encourage you to use the discussions. You can find us on GitHub in the organization NCN Foreigners, which is the project under which the package was developed, thanks to the National Science Center, which founded the grant and our work on the package. We also have a nice package down website for the project, so if you are interested, you can read more. We tried to provide as much detail as possible, so you can find equations, you can find references and use cases for the methods that we have implemented. So thank you very much, and it was a pleasure to be part of the R in Medicine conference. Thank you very much.
Excellent. Thank you so much for a fantastic presentation. And I have taken a look at that repository, and I can tell you that you seem very responsive in your issues. I see some wonderful enhancement suggestions. So I encourage everyone to take a look at that. So we've got about 1 more minute for questions. So I'll open it up.
Okay, I will send the link to the chat. I hope the link is visible on the chat.
It is. We can see it, okay. And I was able to click on it, and it takes us there perfectly well. So
thank you.
Excellent. Well, thank you so much for this very well done and extremely well documented package. And thank you for walking us through this really great contribution. I know that I definitely want to take a look at this, and I'm sure a number of participants today will as well. Thank you so much.
Thank you for having me, and have a nice day and the rest of the conference.